Welcome to Module 4, Detailed Site Assessment. This module involves comprehensive fieldwork to collect technical, socio-economic, environmental, and spatial data. The detailed site assessment marks the transition from validation to evidence-based technical understanding. At this stage, the technical vertical moves beyond confirming that a project exists and begins to develop a granular, engineering-level view of the site. This is where assumptions are replaced with measured realities. Every design decision that follows, generation sizing, network layout, and cost estimation will depend on the accuracy and completeness of the data collected here. Fieldwork typically begins with structured engagement at the community level. Enumerators, acting on behalf of the technical team, meet with the community liaison officer and other local representatives to formally introduce the purpose of the visit. This step is not procedural. It establishes legitimacy and ensures cooperation, which is critical for accessing households, businesses, and infrastructure. Once access is secured, the assessment progresses into a systematic evaluation of existing electrical infrastructure. This includes identifying the presence and condition of poles, conductors, transformers, generators, and end-user wiring systems. The objective is to determine whether existing infrastructure can be integrated or whether a completely new system will be required. Simultaneously, the team evaluates land availability for key components such as solar arrays, battery storage systems, and control rooms. This involves not only identifying physical space but also verifying ownership, accessibility, and environmental suitability. In many cases, what appears to be available land may later become unusable due to disputes or environmental constraints, making early verification essential. The most critical component of this module is load assessment. Enumerators collect detailed data across different user categories, including households, commercial entities, institutions, and anchor loads. Effective load assessment goes beyond recording appliance lists. It requires understanding how energy is actually used, including peak usage periods, seasonal variations, and operational behavior of businesses. Environmental considerations are also documented. Flood-prone areas, erosion risks, and waste management issues can all influence system design and long-term performance. These factors are often overlooked in early planning but can have significant implications if not properly accounted for throughout the assessment process. Data integrity is maintained through geotagged photographs, GPS mapping, and structured data uploads. Daily submission and review ensure that errors are identified and corrected in real time. At the conclusion of the detailed site assessment, the technical team should have a comprehensive data set that accurately reflects the technical, environmental, and socio-economic conditions of the site. This dataset forms the foundation for all subsequent modeling and design activities. The expected outputs include a technical feasibility and assessment report, distribution network maps, single-line diagrams, bill of quantities, and raw data, site documentation, and mapping and lessons learned from the assessment process.